So today I'll be showing you how to create an electromagnet using a few common household materials. What you'll need for this experiment are a couple of batteries, any type of batteries will do, some electrical tape, wire, a nail about 4 inches in length, some scissors, and some staples. These are 1.5 volt D batteries. You could pretty much use any type of battery that you'd like. You can use anywhere from the 9 volt batteries to the AAA batteries to car batteries if you like, although I wouldn't recommend using any car batteries just because it'd be too much. But the stronger the voltage on your battery, the stronger your magnet will be. So we'll just tape these up, get a nice connection here. Basically what I'm doing is I'm just going to tape 4 sides of the battery and then I'm going to wrap it so that we connect it. And so basically we'll have one battery, and if we have 2 batteries at 1.5 volts each, that's the equivalent of 3 volts total. And volt is another word for electric potential or EMF. So those words can be used interchangeably in this case. For now, let's use voltage. So there you have it. We have both batteries connected with electrical tape. The next step in this experiment is cutting the wire. So we have our wire right here. You want to measure out about, I'd say about 3 or 4 feet or so of wire. Right here I have some pre-cut wire with the ends already stripped. And so you want the ends stripped to make a good connection. Basically you can strip the ends with scissors. Just cut it just enough to cut the plastic part, but not too much to where it cuts the copper wire. And so basically you can cut the plastic part off and then you're left with a stripped wire that looks like this. So the next thing we're going to do is we're going to attach one of the ends to the battery and we're just going to tape it down. And right now I'm taping the end of the wire to the positive end of the battery, just because it'll make things easier later on. But you can really tape it down to either side. Any side will work fine. There you have it. So now the next thing that we do is we take our 4-inch nail and we wrap the wire around the nail as many times as possible. The more times that you wrap the wire around, the stronger your magnet will be. Basically, we're creating what's called a solenoid, or a piece of metal wrapped in wire. You also want your turns to be as tight as possible. There you have it. We have the wire wrapped around the nail. And so this can get a little springy here, so I'll go ahead and attach some electrical tape just to keep everything in one place. Okay, so now we have the wire with as many turns as possible, as tightly as possible, wrapped up in electrical tape to keep the wire as close together as possible. Basically we're pretty much done. Let's get all these materials out of the way. You want to take off quite a bit of staples. It doesn't have to be too many. I have about a dozen staples right here loosely placed. And now we have our electromagnet. Let's see if it works. So we're going to take the nail, put it in our wrapped up wire, and we're going to take our naked end of the battery and we're going to touch the negative end, the negative pole of the battery that we created. What this is going to do is going to close the current, and it's going to draw a current from the high potential into the wire wrapped around the nail, and it's going to go into the negative side. And what that's going to do is going to induce a magnetic field. A magnetic field is induced with current, and in this particular case, if I show you the nail like this, the current is going to go clockwise. It's going to go clockwise down the nail, and using the right hand rule, if it goes clockwise, then you should get a magnetic field pointing towards you, and that should create the magnetic field strong enough to pick up these staples. So let's see if it works. Hold the battery steady, and we'll touch the end of the wire to the negative end of the pole, creating our electromagnet. And there you have it. It works. And when I let go of the negative end, most of the staples drop. Theoretically, all the staples should drop, but because the nail is made out of metal, some magnetic field is still located inside the nail. But there you have it. We'll try it again. Without the current, the nail doesn't attract any of the staples, and with the current, it attracts them all. There you have it. Just a fun physics experiment that you can do at home. So have fun.